Right, welcome to lab number 7. We want to determine the Ka values for acetic acid, sodium acetate buffer. We're going to have both the acetic acid and the sodium acetate in there, measure the pH. We will know how many moles of each were added, M times M of L. And from that, using the Henderson-Hasselbalch equation, we can determine pKa of the acid and the conjugate base. And then from that, determine the Kas. And then these are the Kas we'll use to calculate the equilibrium constants for the weak acid, weak base reactions. pH electrodes. Here's one, brand new. It comes in a protected solution. The reason is so that it doesn't dry out. So this is the cover, so when I'm done, I'll put it back and lock it back there. It needs to be wet and remain that way. So what happens? Well, up here, I have buffer solutions. This is pH buffer 4.0. This is pH buffer 10.0. We're going to use these two to calibrate the pH electrode. And then, when we're done, we're going to measure the pH of the buffer solutions we create. So how does the calibration work? So you can get close here. Got something like this. In our directions, we would say press home, and then we would say, okay, press sensors F4. We press F4, and then in this case, there's a temperature sensor and something else. So I'm gonna go here and say I want to calibrate the chemistry sensor and not the temperature part. So what do? I look at that and I go looking for pH. So scroll down till I find pH. Oh, there it is. I press check to let it know that's what I want. Then it'll tell you go F4, and under F4 you look for when it says calibrate. Of course, these directions would be in the manual for you guys to follow. So we are now in calibrate. It doesn't know what I want to calibrate, so when I tell it, hey, not temperature, but pH. So you can see that it reads pH. It's a 2-point calibration, 2 buffer solutions. So what essentially happens is that when I put this electrode in the buffer solution, it establishes a potential, a voltage. Kind of fancy word is potential. And it associates that potential with this pH. Then that's a data point, and then we do it for the other pH 4, pH 10, and then internally it associates the pH with some voltage that it actually measures. And then when we measure the our buffer solutions here, it will directly give us a pH. So right, let's go into pH number 4. We go in there, swell gently. The pH electrode is pretty sensitive. So I go in here and it says I need a 2-point calibration, and the pH is 4, so that is correct. And I look down here and I'll see that it associates a certain potential with this pH. At this point, I'll say read the first point. And then at that point, I will quickly rinse my electrode, put it in the other buffer solution. This is now pH 10. And then I'll go here, and these directions will be in your manual. Scroll down to the second point. So that's the second point. The pH is 10, so that's correct. It reads a certain potential associated with that. And then I say, read the second point. You can't read the first point because then you're overriding whatever you did before. Then you go, okay, and then come out, and then you go to digits. I like the digit mode. Pause. Yeah. So what I'm doing here is just checking that I calibrated properly by measuring either of the buffer solutions. This is supposed to be pH 10. It's reading 9.99. That is good enough. Right. Pause.
3.
All right, so what I have here is 5 milliliters, 5.00 milliliters delivered by the auto pipetter. And I added about 3 milliliters of water. The volume of water doesn't really matter. And so the idea is that when I add the base, I should sufficiently be submerged in solution. So right now, there's just the acetic acid, 5.00 milliliters, and the water. I'm now going to add the base. If this is acetic acid, the base is sodium acetate. So again, 1.00 milliliters. One. Two.
Add the level. Show the level.
Three. At this point I want to mix a little. Maybe I can use the electrode to mix. So I put in a little stir bar there. So I stir the solution, just make sure they're nicely mixed. You can verify it's mixing. You can see the vortex at the top there. I turn that off. And I read the pH. So let's call this 4.02. Right? We are now going to add an additional 3 milliliters of sodium acetate. One. Two. 3. Do the mixing. Turn it off. And read the pH. Let's read that as 4.31 after addition of the second 3 milliliters. So with that, we are done with the acetic acid, sodium acetate buffer. Now going to the next one. The next one is ammonium chloride. So NH4 plus is the acid and the base is NH3. So I'm going to move my sodium acetate out. Bring in the ammonia. Change the pipette tip. Always a good idea to avoid contamination issues. I only have 2 hands. All right, there we go. Adding ammonia now. One. Two. And three. Mix. Turn that off. Put in my electrode. Up and down a little. And then read the pH. Let's read that as 8.06 after adding the first 3 milliliters. Now moving on to add the second set. One. Two. Three. Let's read that as 8.34. 8.34. We are done with the ammonia system. Now moving on to the phosphoric acid H3PO4, that's the acid. H2PO4 minus is the conjugate base. Move that out. Make sure I'm getting the right thing. All of these are 0.2 molar. Change the pipette tip. One. Two. Three. Mix. Up and down to make sure everything is nicely mixed. Read the pH, the first number. Let's read that as 2.03. That's after the first 3 milliliters. One. Two. Three. Nicely mixed. Now read the pH. 2.20. Let's read that as 2.20. We are done with the H3H2 combo. Now moving to the H2H1. Get this out of the way. Change the pipette tip. H2H1. So now I'm adding the H1. One. Two. Three. pH is, let's read that as 6.60. One. Two. Three. Turn that off. Yeah, 6.89. 6.89. Yeah, we're down to the last one. How about that? Rinse in distilled water. Change the pipette tip. Move this out of the way. Bring in my sodium phosphate. So that's, so we have H1 to no H. All right. Weak acid, conjugate base. One. Two. Three. pH is 11. Let's read that as 11.02. 11.03, 11.02, whichever one you like. Okay, 11.03. Wait for that to stabilize. Let's read that as 11.23. That concludes the measurements in the lab. From these, you can determine the Ka of each acid, that is acetic acid, Ka for the ammonium ion, Ka1 for phosphoric acid, Ka2 for phosphoric acid, and Ka3 for phosphoric acid. That concludes lab number 7. See you in lab number 8.